Hey everybody. Welcome to Friday. Happy Friday. So today we're going to talk about vitamins. Before we get started, just a couple of reminders on wrapping up the semester stuff. So everything is looking pretty good. If you either submitted your final project proposal late, I think I've gotten most of those in. So you should have comments back on that. Again, if you got a 0 or a low grade on that proposal, it means you did something wrong. It doesn't mean you just lose all those points. So you have to redo it, resubmit it, and quickly because you're running out of time. We only got a week left. And you still have to actually complete the project. So please get that stuff done. Otherwise, everything else should be pretty much done. We're just going to wrap it up. Let me know if you have questions or if other things come up. Remember, there will be a quiz next week, but there isn't any kind of a final exam in this class, just the project. All right. So let's talk about vitamins. So what you see here, I have some pictures of some structures of vitamins. This is actually a table that I would, if we were in person, I would give this as a handout. But since we're not, we have to do it this way. So vitamins are kind of an interesting and weird set of chemicals because they don't really have much in common. They are what we call micronutrients. We talked about the macronutrients, the carbohydrates, proteins, and fats. That's what you're mostly eating, what you get most of what your body needs from. And then there's also micronutrients, things that your body just needs a little bit of. And that would include vitamins and also minerals. Those are sort of separated in that vitamins are organic compounds and minerals are inorganic, like metals and nonmetals, the other rest of the periodic table, non-carbon based stuff. But in terms of what makes vitamins, as you can see, if I kind of scroll down here, I can make this document available on Blackboard too. There's not a whole lot of commonalities in these structures, except that they're organic compounds. So you can see they all look pretty different. In fact, there's one of them that didn't even fit on here, vitamin B12, which looks like this, which is actually kind of an inorganic structure. It's got a cobalt in the middle. So very, very different there. The other weird thing about vitamins is some of them are not even one molecule. So for example, vitamin A is not just one molecule. It's a whole bunch of different things. You might have heard of like retinol, beta carotene, carotenoids, things like that. If you've heard of those types of molecules, there are several of those that all make up vitamin A together. Same thing with several of these really actually. The vitamin E is not just one molecule, this thing here. It's a bunch of different ones called tocopherols and tocotrienols. So if you ever see like on an ingredient list, it's pretty common, especially in cosmetics and things, it'll say mixed tocopherols. That's basically vitamin E. Also, the letters are kind of all out of order, which I'm sure you've noticed in the past. There's vitamin A, there's a bunch of vitamin Bs, but not all of them. So there's 1, 2, 3, 5, 6, 7, 9, and 12. And then you've got C, D, E, and then it jumps to K. So, what happened to all the other ones? Why did the B ones all get lumped in together? And this all has historical reasons for being this way. So like one vitamin was discovered and then another one was discovered and then like vitamin F was discovered, but then it was realized that actually vitamin F is the same as one of these other ones. So some of these were discovered in different orders or like, this is all in the time before sophisticated chemical analysis. So nobody really these were all discovered by the dietary aspect of it. The fact that if these were missing in someone's diet, they were getting specific diseases. And so there was sort of this thing in these foods that was starting to get known about, but it wasn't necessarily clear for a while after they were originally discovered what they were chemically. And so that's what leads to all this weird classification of weird numbers and stuff. Looking at the chemical structures, you can see some commonalities between some different types. So for instance, all the B vitamins have lots of nitrogen as well as OH, oxygen. You can see that here. even though they're pretty different structures otherwise. Vitamins like vitamin C have, and the B vitamins also have lots of OHs, but vitamin A, D, and E, you can see are more non-polar. So when we talked about polar versus non-polar, water-soluble versus not water-soluble, you can really see that in these vitamins, that they are mostly carbon-hydrogen for vitamin D and E, as well as vitamin A. And that's where we get that those vitamins are fat-soluble instead of water-soluble. So we know fats are mostly non-polar, and so these are vitamins that would get dissolved in your fat or in the fatty parts of your body. So those are some vitamin structures. Hopefully with the work we've done this semester, have some idea of what those kinds of things mean now. All right, let's get a look at recommended daily allowances. I just pulled one. They're a little bit different for different age groups and different sexes, but they're around the same. But one thing I want you to take note of is this is the amount that you need each day of these things. And you can see that these are very small amounts. So that symbol up there, that's a microgram. So that's 900 micrograms, which would be 0.9 milligrams. They're all right around a milligram or way less. Like some of them, like vitamin B12, 2.4 micrograms, tiny, that's 0.0024 milligrams. So very, very, very small amounts of these things. And if we were in lab this semester, you'd have an even better sense of what that is, because like these types of quantities are hard to measure even on our analytical balances in the lab. Like these are really, 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 really small quantities. And if you don't get these vitamins, you can be susceptible to these deficiency diseases. And these are diseases that for a long time killed a lot of people. And in areas where there isn't a varied diet or there isn't enough food, there's still a problem. But these are diseases that here in the US, we really don't see much of anymore. And that's because even if you don't eat a particularly healthy diet, you're still eating a varied enough diet to get these vitamins. So most of these diseases should seem pretty much like you may have never even heard of them. Probably the most famous one is scurvy. If you don't have vitamin C, you can be susceptible to scurvy. Right, the kind of pirate disease, because if you're on a ship and you don't have any fresh or really any kind of fruits and vegetables, you can be susceptible to scurvy. Now, in this country, scurvy sometimes is also a problem among people who do not get enough food or who have psychological or psychiatric disorders that make it hard for them to eat a varied diet. So people who are fixated on particular foods and will only eat certain foods, and then they won't have enough variety to get these vitamins. But when we talk about enough variety, we're not talking about some like you need to eat salads and whatever every day. We're talking about like a ketchup packet, basically. If you eat some ketchup, you've probably got plenty of vitamin C and vitamin A. If you eat some cereal or bread, all our flour is enriched with vitamins, so you're getting plenty. Anything with flour, you're getting plenty of vitamins. If you are eating pretty much any variety of food at all, and this could be like even really bad stuff, like stuff that's really bad for you, you are getting your vitamins. You are not lacking your vitamins. And furthermore, your doctor tests you for these. So when you go for your yearly annual physical, if you go, you'll get blood tests and they'll check vitamin levels. If you have particular problems, they might check vitamin levels and see if that's an issue for you. So you can see over here on the far right some food sources of these things. This is not an exhaustive list. There's lots of different ways to get these things. You'll notice that meat comes up in almost all of them, and that's because animals need these vitamins as well. So if animals are getting their appropriate diet and then you're eating the animals, you're getting the vitamins you need. Now, if you're not eating animals, you're still probably getting all the vitamins that you need. But as those of you who are vegetarian or vegan know, you need to just be a little bit more pay a little bit more attention to your diet to make sure you're getting a variety of stuff. But it's certainly not difficult to do. All right, and then some unusual ones. So for vitamin D, you actually get, your body makes it from being in the sun, and about 5 to 30 minutes twice a week, exposed skin, you'll get your vitamin D. Now, that's not a great way to get vitamin D, actually, because we know that the UV light from the sun causes cancer, or can cause cancer. So it's better to protect yourself from the sun and supplement your vitamin D. And so we add vitamin D to milk, for example. And there are some other ways to get it as well. Vitamin D is perhaps the only vitamin that a large percentage of the population in this area of the world probably doesn't get enough of, or may not get enough of, because the sun just isn't out that much. We don't spend, half the year, we don't really spend that much time outside. So that is a vitamin that you might get tested by your doctor, and they might say, you're not getting enough vitamin D. You got to take some vitamin D. So for example, I take vitamin D pills because my doctor ran some tests and said, you don't get enough vitamin D. And since I've been taking the pills, they run the tests and say, yeah, you get enough vitamin D now. So there aren't, other than the actual diseases, there aren't really symptoms that would tell you if your vitamin levels are a little bit low. So that's why we need to get those things tested. But one of the things I want to talk about today, and kind of an interesting story about vitamins that always kind of blows people's mind when I talk about this in class, is that you don't need to take a multivitamin supplement. So most of these vitamins you are getting from your food. There are a couple that you may have to supplement depending on your body. Vitamin B12 is another one that doctors often test for because some people are deficient in it. But absent those tests, you're probably getting everything you need. And so where did this idea come from that we need to take vitamins, or that vitamins do other things besides prevent these very specific vitamin deficiency diseases? And one person that we can turn to for this, unfortunately, is this guy, Linus Pauling. I don't know if you've heard of him. He is a very influential figure in chemistry and science in general. He was the only person to win 2 Nobel Prizes. He won a Nobel Prize in chemistry for figuring out a lot of the stuff that we've talked about this semester about polarity, like the idea that bonds have their electrons lopsided, and that leads to positive and negative areas, and then that influences properties. We spent a lot of time talking about that. He figured that out. So brilliant scientist. Then he also won a Nobel Prize for Peace, a Nobel Peace Prize for his work on nuclear disarmament, trying to get countries to get rid of their nuclear weapons. And then in like the 70s, he started to have some really bizarre ideas about vitamins. And because he had so much clout as this like eminent scientist, people basically just believed him, even though he was completely wrong. So it's an interesting and kind of sad story. This author, Paul Offit, says he's a man who was so spectacularly right that he won 2 Nobel Prizes, and so spectacularly wrong that he was arguably the world's greatest quack. So if you're not familiar with that term, a quack is somebody pretending to be an expert or a scientist at something, but is really just making stuff up. And that happened. So this happened with him. As the story goes, there's a great book about this, by the way, called Do You Believe in Magic by Paul Offit, the author, who writes kind of about things in medicine and science that people sort of just believe without actual evidence behind it. And vitamins is one of those. For some reason, we don't really know why, he decided at some point that vitamins were the key to curing basically all disease. He thought that there would be a cancer-free future if we all just took lots of vitamins. And he was specifically interested in vitamins A and D and C. And he said if you took big quantities of these vitamins, you could cure common colds, you could cure the flu, and you could be immune or You wouldn't be able to get cancer. And none of that is true. There was never any research that showed that. He got the idea and just decided it was right. And because he had so much, he was so famous in this era. Scientists were famous. They would go around the world giving talks. They would have huge audiences, and people applauding them for being these brilliant scientists. So he had all of this. He had all of this prestige, and he would go around telling people about vitamins. And because he was such an eminent expert in science, people just believed him. And major magazines like Time and Life would write these features about how the vitamin revolution and how vitamins were going to save people. And in the wake of that, a major industry, the supplement industry, started producing large quantities of these vitamins and marketing them as something that you needed. And so if you've ever gone into a store, this is still with us. If you look at the things like cold medicines that say you need to take a bunch of vitamin C. I mean, we've all heard that. You maybe thought that right until this instant, that if you have a cold, you need to take lots of vitamin C to help you get over that cold. That is completely wrong. There's no evidence to that at all. If you take more than your recommended daily allowance of vitamin C, it simply comes out in your urine. It doesn't do anything else for you. And again, if you're having, half a ketchup packet or so, you're getting plenty of vitamin C. So this idea that vitamins can cure things besides those specific diseases that are caused by vitamin deficiencies, that really took hold because of this guy in our culture. And so people really, really believe, you need to get plenty of vitamins. And even if you have enough vitamins, you need to take more vitamins. So like we all took our, Flintstone vitamins as a kid. Many people still take a multivitamin every day, completely unnecessarily. You don't need to do that. And then kind of coming off on this trend, move this over here. People did start to study this stuff because so many people were taking vitamins and people were talking about them. And they actually started finding the opposite, that in some of these biggest studies that I've got cited here, people who took extra supplemental vitamins, particularly A, D, and E, ended up having more health problems. And so no medical association, the American Medical Association, ones from other countries, no major medical association has ever recommended that people healthy people just generally take vitamin supplements. You don't need them. And then adding to all of this is that there is now this massive industry behind it. So you've got this vitamin and supplement industry that has a financial stake in selling as many vitamins as they can. So even though this is all well known, the percent of people who take a daily multivitamin continues to increase and continues to go up, even though we know that that they don't do anything and you don't need them. Now, again, if your doctor says you are deficient in this vitamin, you should take this vitamin, that's a different story. But just for general adults to take multivitamins is unnecessary. Furthermore, the regulatory framework in the US made this easier and easier. So there was something called the Hatch Act in the 90s that said if you call something a supplement, don't need to tell anybody anything about it. And this is fairly dangerous. So before that, after some really high profile, horrible deaths and things, the FDA was formed to require that before you can sell a medicine, you have to prove that it is safe and that it is effective. So you have to prove that it does what you're saying it does. You can't just say this thing cures whatever. You have to actually show that with some studies. And it has to be safe, so it has to not hurt people. And you have to be very transparent about what's in it. How many milligrams, what is the chemical, what are the side effects, all that kind of stuff. Another category that the FDA regulates is food. If you call something a food, you have to have evidence that it is safe for people to eat. So if it's some new kind of additive or something, you have to prove that that's safe before you can bring it to market. There's various mechanisms for doing that. But they created this third category called supplement. So a supplement is not a food and it's not a medicine. It's not a drug. It's a supplement. And so if you call something a supplement, you don't have to do anything. You don't have to tell people what's in it. You don't have to prove that it's safe. And you don't have to prove that it does anything effectively. So anything that's listed as a supplement can contain whatever the manufacturers want it to contain. And if it does end up hurting people, the FDA can pull it off the market, but only after they've shown that it's dangerous. And so that's caused a lot of problems over the years and continues to. One thing we do in class is I'll have, and I encourage you to do this, look up some supplements that you might take or that friends or family, people you know might take, especially workout type stuff. You'll notice that they have these supplement nutrition labels. In fact, let's look some up and just see what we can find here. I'm going to pull up a website where you can buy these things. I haven't looked at particular ones for this class. I'm just let's just look at a couple and see what they have in them. So this is just one that came up. I don't know anything about these. But let's just grab one. It is the Ghost Legend V2 pre-workout. $45. Let's take a look at the label. All right, so you'll notice it has this very, official looking label, kind of like nutrition facts. Nutrition facts are required by law to be on foods, but supplements don't require this. They just put this on here because people will think that it is more legit if that's the case. So even though this is here, there's no regulation that any of this actually need to be accurate. And a lot of studies have shown that certain supplements, even though they might say they contain a certain amount of something, they don't actually contain that at all. Because again, they don't need to. Most of the stuff is just kind of nonsense, unnecessary stuff. Most of these expensive pre-workout things, so if you exercise, the pre-workout supplements are meant to get you like really energized to do your workout, and they have all kinds of fancy sounding stuff. They are almost exclusively caffeine. That's why they work, right? So this has 250 milligrams of caffeine, which is a substantial amount of caffeine. That's a couple cups of coffee that you're essentially drinking all at once. It also has theobromine, which is basically a type of caffeine. That's what's in chocolate that has similar effects. And then it also has some amino acids, taurine and tyrosine, that may have some energy effects, may not. I don't think that's well established. But primarily, you're just eating. When you take a supplement like this, you're really just eating really expensive caffeine. How much is a couple cups of coffee? How much is a couple caffeine pills? If you really need caffeine to get you that energy for your workout, all this other stuff is just a way to charge you way more money for basically caffeine. At least this particular one actually breaks it down and says, hey, here's the caffeine and whatever. Several of these, and I don't know any of them in particular, so I can't, I don't have any specific examples, but if you were to go to one of these stores and look at the labels, many of these actually just say proprietary like proprietary blend on their nutrition label. So they'll just say, oh, this has 500 milligrams of a proprietary blend. And that's basically them just saying, it's secret. We're not going to tell you what's in it. But you can figure it out if it's based on what it does. If it's just meant to give you energy, it's probably just caffeine. And that's because caffeine is cheap. And they're not going to spend a bunch of money on other stuff when they can just put a bunch of caffeine in there and charge you a bunch of money for it. So it's the same thing with this one, right? It's got all this other kind of ATP, peat, and apple extract, as though that's, something important. But again, it's pretty much just caffeine. You've got 250 milligrams of caffeine and another 100 milligrams of a coffee extract, coffee is coffee extract, right? You've got some creatine in here, which is a real thing. But again, this is where that supplement category comes in, again, with the story of vitamins, that if one of the reasons that this came to be, there was this push in the 90s to regulate this stuff and to stop people from just being able to sell whatever, especially with the diet pills that were around at the time that were causing major problems. And the supplement industry had a very successful marketing push. And you can look this up. There's this commercial. Look up a vitamin commercial with Mel Gibson, the actor, where like a bunch of federal agent type guys all in black with guns like break into his house, and he's holding a thing of vitamins, and he's like, "They're coming for my vitamins. Why would they take my vitamins like an orange juice?" And they scared people, and they said people thought, "Oh, the government's trying to take our vitamins." And so then that's how that supplement category got created, was they pushed back. The supplement industry marketed hard enough to get public opinion on their side to say, we need a supplement category. We don't want these things regulated at all. That's where we're at now. So now we have to be really careful for things that fall in that category. They are at best things that are simply benign and we're just wasting money on them. But at worst, they contain things that could really cause problems or that aren't studied. And so I would be really, really careful if you encounter things in that category. All right, so that's a little bit about vitamins. This is not something that's going to be tested on. It's just something I thought would be interesting, something we would do an activity of in class if we were all together. So we'll meet back on Monday. Hopefully your final projects are going well. And let me know if you need anything else.